Now the next problem, boxes in boxes. So before talking about the problem statement, let's see the input statement first, or the input and the output format. Right. So the input says 4, and which is n, and the next 4 lines or the next n lines will contain the dimension of boxes. So this is the dimensions of the first box. So what are these numbers? If we scroll up, we can see that these are basically length, width, and height. But yes, definitely we can interchange them based on the requirement of the solution, and we will definitely do that, and we will discuss how to do it. So here the main problem statement is how many of these boxes can be nested inside one another following the rules. So what are these rules? Box A fits into box B if and only if box A's dimensions, length, width, and height are strictly smaller than box B's dimensions after a possible rotation of box A. So we can rotate the boxes, but rotating a box means swapping its dimension in any order, but the box must remain upright, which is really important. So we cannot put the box at an angle. So some examples are given. So box 1 with dimensions 1, 2, 3 can fit into box with dimension 4, 3, 2, because somehow all the dimensions here are smaller than the dimensions of the second box. But for the second example, 1, 2, 3 cannot fit into the box with the dimension 2, 2, 4, because simply one of the dimensions is equal. Right. So now we are going to solve the problem. But before that, we're going to discuss how to solve the problem, and then we'll solve the problem using Python. Let's follow the input given in the problem. The dimensions are 1 to 1. Right. Okay. Now here we can see that to compare two boxes and their dimensions and to find out whether this box fits in this box, we have to actually calculate or compare different combinations. So instead, what we're going to do, after taking the input, we'll sort these dimensions and make it something like this for each box and the dimensions. So that way it will be easier for us to compare two boxes. We will just serially compare the dimensions of two boxes, and we will decide whether the first box fits in the second box. Now there will be another function that we will use to sort the boxes based on their volumes, because we can confidently say that if the volume V1 is greater than volume V2 or equal to V2, then V1 will never fit in V2, because for a box to be inside another box, definitely the volume has to be smaller as per the condition. So this is another thing that we will write. So in the main solution, what we will do, we will keep track of lengths for each box, and we can keep it in the chain lengths. Initially, all the length of the chains will be 1, and that will be for all the boxes. Now let's say we have a sorted list of dimensions of the boxes, and the sort is done based on volume. So this is the first box, this is the second box, this is the third box, this is the fourth box. Just imagine that this has dimensions as the values. Now I'll start from the first box, and I'll go and iterate over the boxes, and I'll check. So for each box, all the previous boxes, do they fit in the next box? If they do, we'll add 1 to the chain, and that's how it will be added, and the maximum will be added or updated in this chain lengths. Now let's say we have the dimensions sorted. So they're sorted by volumes and they're sorted in this corresponding dimensions as well. So we'll keep we'll keep track of the chains in a list, that is chain lengths. It will be initially 1 for all the boxes. So I'll start from the first box and then I'll compare all the previous boxes. Since the first box does not have any previous box, so I'll immediately go to the next one. So for this each element, it will start from the previous boxes and it will check or how many boxes can be nested. So maybe let's consider the third box. So what will happen for the third box? The first, we will check whether first box fits in box 2. If it does, then the corresponding chain length for this, the index is 2. The corresponding chain length will be updated based on whichever is higher, the length previously or the length for this one. Now again, we will check for the second box and the third box. If second box fits in third box, then we will update this chain length again and we'll take the higher value. So that is how it should be done for all boxes. I would say this is a brute force, checking for all the boxes and to find the chain lengths or the nested lengths. Finally, we will have the answer that will be found from this chain lengths and we'll return the maximum value from this chain lengths. So now let's jump to the solution. To solve this problem, I will use the exact same process. I'll take the inputs in the main function, then I'll do some processing based on the necessity, then I'll use another function to solve the actual problem. The function will be called in the main function and will return the answer, and I will print the answer in the main function. But yes, for this problem, I'll use some other helper function for the main function, or I'd say the main solution function, so that we can read and understand the whole process sequentially and in a better way. This also improves the readability of all the functions and the whole code. So let's start. So in the main function, I'm taking the input. The first line of input will be n, and I'm converting it into integer. Now I'm writing other functions that will be used in the solution. So the first function is max chain length, where the actual solution will be written. Then this is another function that I will use to calculate the volume of each box. The next function is fits in. So this function returns or tells us whether box 1 fits in box 2. Now I'm defining boxes. This will be a list. It will contain the dimensions of all the boxes. So now I'm going to run a loop using the n, and it will take inputs of all the dimensions of the boxes. Since there will be 3 numbers in each line and the numbers will be separated by a space, I'll use the map function to convert all the characters into integers after splitting them using the space. And finally, that will be converted into a list. And let's see how it does. So yes, I'm taking the input and then I'm splitting that. And then I'm sorting the dimensions of the box as we discussed previously. And now I'm appending the box or the dimension in the boxes list. That way, I'll have a list of lists that contains all the dimensions of boxes. And now here result is the variable that will take the output from the max chain length function. And from this main function, I'll print the result. Now let's write what the fits in function do. It will compare the dimensions of box 1 and box 2 sequentially, and if any of the dimensions of box 1 is greater or equal to box 2, then it will return false, because that way we can say that box 1 doesn't fit in box 2. But if all the dimensions sequentially are smaller than box 2, then we can say box 1 can fit in box 2. So yes, I'll run this loop for all the dimensions sequentially, and this will be the condition that box I is greater than equal box 2. It will return false. But if the comparison is done for all the elements and it gets out of the loop, that means it will return true. So box 1 can fit in box 2. Now we're going to talk about what this volume function does. It simply returns the volume of a box. Now we'll start working with this max chain length, which will actually calculate the solution. So the first thing that we'll do, we'll sort the boxes list based on the volumes of the boxes. This is the volume function that we previously initiated. Now this is the chain lengths list. Initially all the values will be 1 for all the boxes. So that's why it's multiplied by n. So there'll be n elements. Now I'll start from the first box of the boxes list. And this is the nested loop. Check for all the combinations. And now I'll check whether each box fits in the next box. That way I can say that there can be nesting. And here our target is to find the maximum length of nesting, or maximum length of the chain. So here the chain lengths is updated. Now based on this, the chain lengths will be updated with the maximum value of the two combinations, and finally I'll return the maximum of this chain lengths list. And that will be our answer. Now we're going to check whether there is any error, and we're going to run the code and see if the test case works for this. So this is the given example, and this is the answer. And I believe the answer matches the expected output in the example. So I think the code runs, and we're going to submit this in the website. So this is the website, and we're going to submit the code here. We have selected the compiler as Python. So let's submit it. And I've already submitted it previously. And this time it runs properly. So we're successful with the solution. So this code works for all the test cases, and this is the solution for this problem. Thank you so much. Now we're going to the next problem.